Hi guys, here's a video on lesson 6.2, which is graphs of inverse functions. What you'll need is your Springboard book, and it starts on page 93. You'll need a pen or a pencil to take notes, and you may want a calculator, but you probably don't even need one. Let's get started, page 93. So, our learning targets are that we are going to use composition of functions, so composite functions, what we were doing in activity 5, to determine if the functions are inverses of each other. Okay, so inverses, what we were doing in the last video. And then we're also going to graph inverse functions and identify the symmetry. Okay. So it says here you can use the definition of inverse functions to show that two functions are inverses of each other. So maybe you remember from the last lesson that two functions are inverses of each other if and only if, let's say like f of g of x equals x and g of f of x equals x. So basically what that means is that two functions are inverses of each other if you compose them inside of each other and they come out to equal x, both of them. Okay, so here's an example. They give you, example A, they give you f of x equals 2x minus 4, and the f inverse of x is x plus 4 over 2. So then what they do is they compose it. So the first way they do here, so f of f inverse of x, and they end up getting x. And then they do it the opposite way. So f inverse of f of x, and they also get x out as the solution. Okay, so that means that those two functions are in fact inverse functions. It's kind of like a way to check your work. Okay, so that's what we're going to do in part A, and then I'm going to have you guys try it on your own in part B. But the first thing we want to do is actually find the inverse of a function and then use the definition to prove that the functions are inverses. So again, first thing I'm going to do is find the inverse of 4x minus 14. And we did that in the last video, so we know the first step is to change it to a y equals. So y equals 4x minus 14. Next step is to switch your x and your y. Next step is to solve for y, so I would add the 14 over. And then I would divide by 4 on both sides. So then I know y is equal to x plus 14 over 4, but we're going to write that as f inverse of x. Remember, that's your proper function inverse notation. Oops. Okay, so that's your first step. We found the inverse. Okay, now this is the new part. This is where we need to check. So what we are going to do, and I'm going to use some different colors here, is we are going to compose the functions both ways. So I'm going to do f of f inverse of x. And then I'm also going to do f inverse of f of x. Okay, so the first way, we need to take our inverse function and plug it in for x here. So that would look like 4 times, whoops, why is that happening? Let's see if I can't move that up. There we go. Okay, let's try that again. 4 times this whole thing. Okay, so instead of this x, we're plugging in x plus 14 over 4. And then it ends with a minus 14. Okay, so I plugged my whole f inverse in. And now what's going to happen here is that these 4's are going to cancel. 4 times x plus 14 over 4, the 4's cancel. And you're left with x plus 14 minus 14. Okay, well, obviously the plus 14 and the minus 14 are going to cancel, and you're left with just x. So far, so good. We know f of f inverse equals x. Okay. Then we've got to check the other way. So now we need to plug, so this is f inverse of f of x. So now we need to plug this whole thing in here. So I'm going to use some parentheses and write that as 4x minus 14. Plug that in for x. And then write that as plus 14. That's your whole numerator. And then all over 4. Okay, well, again, I wrote it in parentheses, but I know that this is 4x minus 14 plus 14. And again, those are going to cancel. So then you would be left with 4x over 4. And the 4's are going to cancel to leave you with x. So again, checks out that we're good to go because we composed these two functions both ways, and both times we got x. So we know that yes, they are definitely inverse functions. We have proved that. Okay. All right, so go ahead and pause the video here, and I want you to try part B. First, find the inverse, and then go ahead and prove that the functions are inverses. All right, hopefully you paused the video. And in red is what I did to find the inverse. Okay, so you have g of x, and this is your inverse function, g inverse of x, 2x minus 6. And then up here in green, I did g of g inverse of x and got x. And in blue, I did g inverse of g of x and got x. Okay, so again, that is how to prove that two functions are inverses of each other. All right. Cool. Let's go ahead and move on to the graphing. So we're going to skip that check your understanding. And then we're on page 94 now. And it says you can use the relationship between the domain and range of a function and its inverse to graph the inverse of a function. If xy is a point on the graph of a given function, then yx is a point on the graph of its inverse. And that makes sense. So when we're talking about inverse functions, basically what happens is your ordered pairs just flip-flop. So they go from xy to yx in the inverse. And your domain and range also flip-flop, which we'll talk about. Okay, so it says complete the table of values for f of x equals 3x minus 2. So let's go ahead and do that here. F of x equals 3x minus 2. So let's first plug in negative 2. 3 times negative 2 is negative 6 minus 2, negative 8. 3 times 0 is 0 minus 2, negative 2. 3 times 3 is 9 minus 2, 7. And 3 times 4 is 12 minus 2, 10. Okay, so let's go ahead and plot those points. So we have negative 2, negative 8, 0, negative 2, 3, 7, and 4, 10. And we're going to go ahead and draw a line through those. Beautiful. Okay, so now we know how to find the inverse algebraically, but if we want to find it graphically, all we have to do is switch all of those xy coordinates to be yx. So instead of negative 2, negative 8, it would be negative 8, negative 2. Instead of 0, negative 2, it would be negative 2, 0. Instead of 3, 7, 7, 3. And instead of 4, 10, 10, 4. And then we could go ahead and plot those points. So -8, -2, -2, 0, 7, 3, whoops, and 10, 4. And that would look like this here. Beautiful. Okay, so these two functions, the green one was our original, and then this would be your f inverse. So green was our f of x, blue would be our f inverse of x. Okay, so now number 4 is going to ask you, what do you notice or what do you think the line of symmetry is here? Okay, so what do you think the line of symmetry might be here? Okay, and this is actually kind of tricky, but it's actually that perfect diagonal line, okay? And that perfect diagonal line is y equals x, okay? Because you're thinking of it, it has like a y-intercept of 0, and that's where it would start, 0, 0. And then it goes up 1 over 1 as the slope. So up 1 over 1, up 1 over 1 would make that perfect diagonal line. So y equals x is the diagonal line. And that's what it says here, sorry, in number 6. It says show the graph of y equals x as a dotted line on the coordinate axes in item 4. Describe any symmetry. So you should be realizing that those inverse functions were symmetrical about the y equals x line. Okay. Then this next part, let's go ahead and take a look at this. It says to find the inverse of x, f of x equals x minus 4. So I'm going to do that really quickly. You guys should be able to do this too. Step 1, step 2, and step 3, you would add over that 4. So my f inverse is x plus 4. Okay, so now it says to graph f of x and its inverse. So let's go ahead and do that. So it's f of x, I'll do that in black, was x minus 4. So I would go down to -4, and I would go up 1 over 1. And that would be like this. And then in blue, I came up with the inverse, and I did that by hand, but again, you could do it graphically by just switching your ordered pairs. And so that would start at +4 and go up 1 over 1 as the slope of 1. Okay. And then again, it says to draw a dotted line for y equals x. So again, that's that perfect line, diagonal line. And what you should be noticing again is it's symmetrical, okay? So it says for part B to describe any symmetry that you see, and this is what I want you guys to jot down. This is important, but inverse functions, so all inverse functions, I know we just did 2 examples, but all inverse functions are symmetrical about the y equals x line. Okay, so that's kind of another way to check if 2 functions are inverses of each other. All right, and like I said, I would jot yourself that little note there. Okay, all inverse functions are symmetrical about the y equals x, or the diagonal line. Okay. All right, and we're going to skip over these, check your understandings, and do some more practice in our next Zoom class period. Okay. If you have any questions, let me know. Other than that, have a great night. Bye-bye.